Hello once again, Year 10. I'd like to thank you firstly for your continued engagement with the remote learning programme that we have implemented. We have actually almost come to the conclusion of the Module 4 teaching we aim to do this term, and that really is a credit to the hard work the overwhelming majority of you are putting into this. I thought once again it would be really useful if I spoke through some of the more difficult problems from the preceding week's work. And as a consequence, we have 3 questions that I'm going to go through today. Feel free to skip through this video until you find one that you have struggled with. If you haven't struggled with any of them, that's fantastic. The first question I want to look at is this one here. The time series graph gives some information about the number of umbrellas sold in a shop in the first 6 months of 2015. The sales target for the first 6 months of 2015 was to sell a mean of 65 umbrellas per month. Did the shop meet this target? Show how you get your answer. So in order to approach this, I need to work out the mean over 6 months. So that means I need to use my graph and each time read off the number of umbrellas I've sold. So here I'm selling off 54 umbrellas, it looks to me. Here I'm selling off 84. Here I'm selling off 72. Here I'm selling off 94. Here I'm selling off 52. And here I'm selling off 26. And so my average value over per month, over those 6 months, will be 54 plus 84 plus 72 plus 94 plus 52 plus 26, all over the number of data points that I have, 6. That is, add all of your data points together, divide by the number of data points you have. So I take my calculator, I'm doing 54 plus 84 plus 72 plus 94 plus 52 plus 26. I'm dividing that whole thing by 6, which gives me 63.7 umbrellas on average, and therefore my answer is no, they did not meet their target because 63.7 is less than 65. The second question I want to look through is a Venn diagram question. You'll have noticed that some of the work this week was about practicing skills you should already have gained in lessons. So this question here tells you that the universal set, epsilon, is 60 paintings, that T is paintings from the 20th century, B is British paintings, and it says a painting is chosen at random, it is from the 20th century, work out the probability that it is British. So the first thing that's happening in my mind here is this is screaming out to me a given that probability. This is the probability it is British, given that it is from the 20th century. Now there are 2 ways you can approach this, and you may have been taught both or either. You can use a formula. Probability of A given B is equal to the probability of A intersection B divided by the probability of B. Or you may use a Venn diagram. Personally, and the advice I've given to my classes, the Venn diagram method is much more intuitive, much more logical, and much easier to get your head around. But I will show both methods. So the first thing we need to do, therefore, is work out X. I know that my whole universal set is 60 paintings, so that will be equal to 10 plus x brackets x minus 2 plus x plus 2x plus 8. So 60 will be equal to 10 plus x squared minus 2x plus x plus 2x plus 8. I'm going to collect all of my terms. My constant terms are 10 plus 8, so 18. Then I've just got one x squared term, and then I've got minus 2x plus x plus 2x, so that's just plus x. So I have a quadratic equation that I want to solve. So I'm going to subtract 60 from both sides, because to solve a quadratic equation, I want to set my equation equal to 0. X squared plus x, and I've got 18 subtract 60, which is minus 42, is equal to 0. So I'm going to factorise that. I know I don't have any coefficients on either of my x's, because I just have one x squared. And then I'm looking for 2 numbers which multiply together to give minus 42, and add together to give plus 1x. And so I'm going to have plus 7 minus 6. And therefore x equals 6 or minus 7. And if I look at my values here, I can't have minus 7 people, paintings, that are from the 20th century and British. So, because I know x must be greater than 0, I know therefore that x is equal to 6. And at this point in my working, I'm going to go back and I'm going to fill in my numbers. X is 6, therefore 2x plus 8 is 12, plus 8 is 20, and x brackets x minus 2 is 6 times 4, 24. And now I can actually look at my question. I want a painting being chosen at random, given that it's from the 20th century, working out the probability that it is British. So that means I'm choosing one of these paintings here. I'm choosing one of those 30, because there are 30 paintings from the 20th century. And if I know it's from there, then there are 6 paintings that are British that are also from the 20th century. So that is 6 out of 30, which is 1/5. Now I did mention a second way to do this, and that's using your formula. The probability of A given B is equal to the probability of A intersection B over the probability of B. So in this case, the probability of being British, given that it's from the 20th century, is the probability of British intersection 20th century over the probability of being from the 20th century. So the probability of being British intersection 20th century would be 6 out of 60. There are 6 that are in that little intersection. And then the probability of being from the 20th century would be 30 out of 60, which is 6 out of 30, or 1/5. So the same final answer. So you can answer this in either of those ways. But personally, I think it's easy to just think about it intuitively. I know it's from the 20th century, so there are 30 possible paintings that I can be choosing from, and I want the probability it's British. 6 of the 30 I can choose from are British, and therefore 6 out of 30, which simplifies to 1/5. My third question, and I think this is probably the most commonly confused question of this week, certainly amongst my students and amongst a number of other classes I've looked at as well. 44 students completed some homework, and the histogram shows information about the times taken. Work out an estimate for the interquartile range. In your working, you must show the lower and upper quartiles. That's to help MathsWatch mark this. But it is also a useful hint as to what you should be doing. This is a very difficult question, there's no doubt about it. And it would be a grade 8 or 9 question towards the end of the exam paper. But we are a grammar school, and therefore we should all be aspiring not only to be able to get this correct, but to be able to do it quickly. So, 44 students complete some homework, and I want the interquartile range. So my interquartile range is my upper quartile subtract my lower quartile, or in this case, my 33rd person subtract my 11th person. Right, that's 3/4 of the way into 44 and 1/4 of the way into 44. So if I work first with my 33rd person, I'm just going to very quickly work out how many people are represented by each bar. So this bar is equal to 5 times 1.4. So I can type all these things into my calculator, or I could do them in my head, 1.4 being 7 over 5. Then I have 10 times 0.8, so that's 8 people. Then 10 times 1.4, that's 14 people. And then 15 times 1, that's 15 people, which makes my life an awful lot easier. So to find the 33rd person then, because 7, 8, that's 15, 29. So I want to be 4 people into this bar. In other words, I want to be 4/15 of the way through this gap here. So the gap is 15. So I want, let's write this somewhere else. So there are 15 people in that bar, and I only want to know how far to advance along that bar such that 4 people are counted. So I want 4/15 of the width of that bar. 4/15 of the width being 15 is just 4. So I'm at 25, I'm advancing 4 people, So that's 29. My 33rd person, I estimate, and it is only an estimate because I am assuming that people are uniformly distributed along this bar. Not necessarily true, but I'm estimating that my 33rd person is at 29 minutes. Same approach for my 11th person. I go through the first bar, 7 people. I want another 4 people in my second bar, so I need to advance 4/8 along the width of my bar. 4/8 is a half. My bar is 10 minutes long, so a half of that is 5 minutes, and therefore my 11th person is at 10 minutes. And that means my interquartile range is 19 minutes, and I have my value. So that's using a lot of tricky concepts there, but really the only one that I would expect to be difficult for you is working out where, for example, the 11th person is. Just advance to the beginning of the bar that contains the 11th person and work out what proportion of the width of the bar you need to advance along such that you can reach the number you want. I hope that's been somewhat helpful. Remember that you can always ask me or your teachers for help with any of the questions that you're working on MathsWatch, and we will all do our very best to help. Other than that, keep working hard and you should be fine. Thank you.